what does the answer say for number 13? It says 1 over 32.
Right.
That's a typo. It should be 1 over 4 to the 5th, which is 1 over 1024. So I know that messed a few of you up. Okay. So when you see something like this, I don't know about you, but I don't want to raise 16 to the 5th power. That's way too much work for my brain. So I'm going to do the root first. Okay, so that says take the square root of 16, which is 4. And then once you've done that, once you've taken care of that, that 2 disappears, and all you have left is raising 4 to the negative 5, which is 1 over 4 to the 5th, which is 1 over 1024. Okay. The other question up there is 72x to the 3/4 divided by 9x to the 1/2. Okay, so this is 2 separate fractions. You can do the numbers first, and then you can use your exponent properties with your variable expression. So 72 divided by 9 is 8. And then in order to subtract these, you have to change to like denominators. So 1/2 is 2/4, and when you subtract that, you get 8x to the 1/4, and it's fine to leave it just like that. You don't have to convert it to radical. All right. So let's see. Yep. I'm not putting it anywhere. Okay, and then Cicely had number 29. Is that right? 28. Is that from the homework? Or okay, so number 28. From the homework looks like this: 3 square roots of 75 plus 5 square roots of 108. And I suggest anytime you have to simplify your square roots on the side of your paper, you quickly, really quickly, just put down, the first 4, 5 or 6, 7 or 8 perfect squares like this, so that you can look for perfect squares. So the first thing is you can't add these because they're not like. You can only add things that are like in mathematics. So your hope is that by simplifying this radical and this radical, you can find a radical that they have in common, so you can squish them together. Okay? So the minute you look at 75, which perfect square do you see as a factor or a divider? 25, right? 25 goes in. So this is 3 times the square root of 25 times the square root of 3. Now, the minute you do that, your only hope, because that's a perfect square, your only hope of putting these 2 together is if 3 divides into 108. Otherwise, you're not going to be able to put them together. You could simplify them a little bit, but you're not going to be able to squish them. So a little rule of thumb is you add up your digits. 1 plus 0 plus 8 is what number? And since 9 is divisible by 3, 108 will be divisible by 3. It's 36 times. So it's 5 times the square root of 36 times the square root of 3. So this makes you happy because it's a perfect square, and this makes you happy. Okay? So now you finish it off. That's 15 square roots of 3 plus 30 square roots of 3. And now you squish them together and you get 45 square roots of 3, and you're all done. Okay? So had you been able to simplify this, but they didn't contain a radical in common, you would have just left it as 2 terms. Remember, terms are the pieces of an adding or subtracting problem. That's language you should definitely have down, terms. Okay, what else is going on? I don't care about rationalizing the denominator. I didn't give you any homework there, so you can forget about that. I'm not gonna do that kind of problem. So what does that say up there? Who? Oh, Sonia. The same thing here, Sonia. 108 will have a square root of 3 in it, and the square root of 27 will have a square root of 3. So if you simplify them,
I think that was number 28.
yeah, there's probably just a little bit of a variation on it, right? So that should help you. And over here, Brendan put up a straight multiplication problem. Remember, in Brendan's problem here, those parentheses are doing nothing at all, except for it's just decided to group this. It's just this multiplication problem. That's all it is. It's 4 things that you multiply. You multiply your numbers, and then you have your exponent properties, and it doesn't matter that we have fractions here. You put them together just like you always do by adding, but in order to do this, you have to change this to 2/6. So 2/6 and 1/6 makes 3/6, which is the same thing as 1/2. Okay, so that's all you do there. And then the bottom one.
The question was, it was about the birthday.
Oh, the birthday?
So the guy was gonna said, take this much cake, give it to the whoever's having the birthday, and they would take the other half of it.
Oh,
What
okay.
was left.
Okay. Let's see. I don't really want to do all of this because it's going to take too much time, but let's see where you're going here. You took the square root of 9 first, and you got 3, so you got 3 to the negative 3 plus 3 to the negative 3, correct?
Yep.
And you got 3 to the negative 2 plus 3 to the negative 1. So here's my first question that you've got to be able to differentiate. Can I use my exponent rules in the numerator or the denominator? Can I use my exponent rules and put those together? What does mad sex apply itself to? What operations? What's the M for mad? What operation? Multiplication. Did I tell you guys about mad sex? Oh. That's, all right. And then D is for divide. This is how I taught my Math 106 class to remember their first 2 exponent properties. So thank you. So let's see, do we have agreement on any question? Oh my gosh, 3 out of 4. Woo! We're on a roll today. So we all agree that number 1 is false. What's the answer? It's not possible. We cannot divide by 0. It's undefined. That's the mathematical answer, undefined, which means we cannot define the division problem by writing a real number as a result. So this is false. You can never have your denominator equal 0 and perform an operation of division. Okay? Not allowed. Okay? 0's not allowed in the denominator. Okay? So 0 doesn't get into that club. All right? It's just like women, they can't play in the Masters in Augusta, Georgia, right? You can't play on that course. So they let him now?
Well, they let
Who'd they let?
CEO
Of Google?
Yahoo.
Oh, Yahoo. Oh, probably because she played a couple $1 million. Oh, okay. Well, I guess you have to be rich or something. Okay, the next one says, everyone agrees that in order to add those, you've got to change. In order to add or subtract anything in mathematics, they have to be like. That's all you have to remember. It's a simple idea, but it's one you can confuse with multiplying and dividing. Like radicals, Eric, please, like terms, like anything, okay? And this is the only one where we have some discussion. So the last table said true and everybody else said false. So one of the tables that argued this, we know what the table 5 did. They squared this and they squared that, thinking it was what operation in here? Multiplication. If that said 3 times x squared, sure, the exponent comes down and applies itself to multiplication or division. That's addition. So what does it mean? You got to go back to your definition of squaring. X plus 3, x plus 3. So what's our answer here? X squared plus 6x plus 9. So if you look at tonight's homework, I told you to pay particular attention to one of your, to a table in this section, because this is a biggie for students, okay? When you square a binomial, your exponent properties do not apply. You have to go back to what it means to square and then use FOIL. Okay? And then the last, yeah, Sonia? What does your top of your lecture notes say for today? Your lecture notes, did you pick them up? Yep, we're doing P4, P5, P6. The first 2 are self. This is P4. No, this is not on the quiz. Yes.
Sorry, I didn't mean to take you off course. I make everybody stand.
That's where you always look for your materials is back there when you come in for the week, okay?
And when you turn things back,
Always in the folder, yep. Okay, so can we continue, folks? And the last one, everybody agrees, is just 2 times 6 is 12. X to the third times x to the fifth. Again, we're multiplying. Exponents come in. Exponents always applies to the multitudes, right? The multitudes, multiplication and division. Y to the second times y to the negative 2 times y squared is y to the 0, which is always what? 1, as long as y is not 0. That's the only time it doesn't apply. Okay, so just a quick recap today. These are all self-review. This is just like using FOIL and adding polynomials. This is a little bit on factoring. Your factoring has to be strong for today's class or stronger. So if you're a little weak on your factoring, that we spend 2 or 3 days on that, at least 3 days in Math 096 or 106. So that's the type of thing that you have to assess yourself and do the problems as needed. Now remember, my math lab only has selected problems that I've put in there. You should really look over either your textbook that you have in the binder, your hardcover book, or your e-textbook at all of the problems, because there's some really nice true-false questions. There's some vocabulary and concept problems at the beginning. You know, you really should use what's available to you and not just do the minimum, particularly if you feel like you need more review on something, okay? Now, I tried to go into your homeworks last night, and those of you who didn't get 100% on class 1, I tried to make little, like, helpful hints, and it came up as a little bubble on my end. Like, if you had one of the problems that you only got, say, like A, you got A right but not B, or you were having a problem, I went in and gave you a little hint. So I don't know if some of you got those little messages or not. Did anybody get the little hint messages? Because not everybody had 100% going as of last night anyway. Nobody got the little hints? No? Well, yeah, if you didn't have 100%, I went in and on some of you and helped you. But let me know how you see it, because I'm really curious. I thought that was like a really cool thing I could do. I hope you don't feel like I'm being a voyeur, but I'm just trying to help out a little bit. Don't forget, quiz 1 is on Wednesday. Try to get here the half hour, meaning 8:30, if you want some extra time. Don't forget, you can bring in a little 3.5 by 5 index card like this with some notes on it. These are on my door if you need them. If not, you can just take a little piece of paper that's about the same size. I'm not going to be checking it, so. Yes, yes. Answers to the syllabus are due today, and I sent an email to everybody to bring their graphing calculator in today, which I will have one up here to look at, and I have a few that you can sign out if needed. Please. Then you can get them other places. Look, folks, Wednesday, you really need them. Okay, so try to get one by Wednesday. I've handed out the rental graphing calculator forms. I have more. Renting it, you can rent it for $30, and that's after class if you need to do that. I don't really want to take any more class time, okay? So let's get going with today's material. Again, polynomials and factoring, a self-review. So here's a rational expression. That's what we're going to be focusing on today. Rational expressions, including this idea called domain, which I think may be new to many of you. So you want to start us off, Joe? Is that all right, Joe? Okay. Okay, so there's the rational expression. Do you notice what I have underlined in the word rational? Ratio. So a rational expression is always a division problem like this. And if you covered up the denominator, what you have in the top is a simple expression. It's 250 times x. And what you have in the bottom is 100 minus x. Each of those are in and of themselves polynomials. This is what we call monomial because it's just one term. And what do you think we call 100 takeaway x? How many terms? 2. So what do you think we call it? Binomial, right. So that's a monomial divided by a binomial. So a rational expression is simply 2 polynomials divided by each other. And they could be these special named ones like monomial and binomial, or you could have something with 5 or 6 terms in the top and bottom. So at your table, answer the following 2 questions and check with a neighbor or 2 to see how you're doing. So first one is to find the cost, and our unit is in millions of dollars to remove 20% of the pollutants, and then what percent of the pollutants can be removed for a cost of 375 million. So work on those together and we'll see how we do. Okay, let's do this together, folks, because we'll never get through the class if we take this long on the first question. Okay? Folks, please, x%. X is the percent. In this case, the value for x is 20. So you put 20 in for x and you do your work from there. So 20 times 250 is what? 5,000. Divided by 80. Chop off 10, divide both top and bottom by 10, and you get 500 over 8, which is the same as 250 over 4, which is the same as 125 over 2. I don't have a calculator, which is 62.5 million. Okay? What percent of the pollutants can be removed for 375 million? So now, what does this expression represent? What is, in words, what does that expression represent? It represents the cost right here. It describes the cost. So this is the same as the cost. Okay? So what percent can be removed? This is a ratio or a proportion, excuse me. So you can do your cross products to solve this. You get 375 times 100 minus x equals 250x. And then it's just a linear equation to solve. 375 times 100 is 37500 minus 375x equals 250x. So 37,500, you add 375x to both sides, that's 625x. And now you divide, I don't want to do that in my head. Now you divide 37,500 by 625, and we get 60%. So 60% of the pollutants for 375 million. So you can see that as you try to remove more and more of the pollutants from this river, what's going to happen to the cost? What happens to the cost as you try to remove? It goes up, right? And that makes sense, doesn't it? It's a more costly adventure the more polluted the river is. Okay, so one of the things that we want to show you today with this particular problem is how you can use your graphing calculator to do a lot of this plugging in the work for you. So you, and if you've never done this, this is a great little feature. So this summer when I wrote this up, I tried to highlight all of the pieces of your calculator that you're going to use here. So a quick way to fill in a table. So here's some pollutants here, 30%, 50, 80, 90, 95. And what we're doing here is we're looking at what happens to the cost as we get closer and closer and closer to what? 100%. Now the question is it really possible to remove 100%? So that's the question. And so let's take a look at the cost. But in a way, your calculator can do all of this automatically for you by using this feature. So if you take a look at your calculator, and if you don't have a calculator, I think I have 6 up here that you can sign out right up on the board. So you have to come up very quickly, please, very quickly, so we don't waste much time. Haley put 602 up there, 600 up there, Kyle, 604, Megan. I don't have as many as there are people. You might have to share. Liza put 606 up there. Curtis do 603. And Logan, there's lots of people, and there's 607. Okay. 607. Okay, so folks, do that quickly and get a seat, okay? So the first thing you're going to do, and I'll show you everything up here on this big calculator on the screen, okay? It's like the big something in the sky, you know? All right, so let's clear this off. So the first thing you're going to do, folks, is you want to put your expression that we're trying to evaluate into your calculator. So you hit your y equals button, which is right here, y equals. It's right here, y equals. Hit that. Now, I'm going to clear mine because I had absolute value of x in there. So now you write 250x divided by. But the only thing you got to be careful of is that you're dividing by a binomial. So that's got to go in parentheses before you enter it in your calculator. So you should do something like this. 250, x is right here, right beside the alpha button, x, divided by, now use your parentheses, which is right here, 100 minus x. And then you use this minus, the subtraction minus. This minus down here means negative or opposite, okay? All right, so now you've entered your expression. Now the really cool thing, once you've entered your expression, is you can get all these values all at once. So then you press second window. You see right above window, you see TBL set. That means set your table, right? We're going to have dinner. So you hit second window. And now it says, where do you want to start? So we're going to start with the value 30. So right in there, I put the number 30. Okay, that's where I'm going to start. I'm going to increment by 10 because at least the first 1, 2, 3, 4 answers are incremented by 10. So I can do 10. And then it says independent. Enter to highlight ask. So notice I'm going to enter ask. And what that means is I'm going to ask it to calculate 30, 50, 90, 95. If you do auto, let me show you what happens if you do auto. And then dependent is going to be auto. But if you hit auto here, if you go over and hit auto, what's going to happen, then you go to your table right here above graph. It's going to automatically do 10, 40, 50, 60, 70, 80, 90. It's just going to do it automatically for you. So you can start to fill these in right now. So for 30% of the pollutants, it's 107.1 million. I'm just going to round to the nearest tenth. What is it for 50? What does it say for 50? 250. Second table. Yep. I think it just comes automatically. 80 is what? 1,000. So what is that? 1,000 millions or a billion, right? So that's equal to 1 billion, right? And then at 90, it's 2.25 billion or 2,250 millions. Okay. So notice these are all incremented by 10. So if I go back to my table, I want to start now at 95. So I'm going to go back and set this at 95. I'm going to increment by, say, 1. But now I'm going to ask it. I'm going to go in and actually say, the calculator is going to say to me, instead of giving me a table, what do you want me to figure out? So it's saying whatever amount of pollutants I put in, you're going to tell me what it is. I'm not going to automatically figure it out. But I will spit out the value of the cost. So I go over to second table. And now see, it's waiting. It's waiting for me. So what do I put in for my value? It's asking me, what do I want to know? How much does it cost for 95% of the pollutants? So let's put that in. And when I hit enter, it will calculate it for me. There you go. So 4.75 billion or 4,750 million. Wow, it's getting really costly. What's the next one I want to know? 98%. Let's see what happens. Oh my goodness. Now we're up to 12.25 billion. just for 3% more. It almost tripled. Any guesses for 99? 24,750. It's really getting costly. So let's scoot right up to 99.99. 99.99. 2.56 times with a little E6. What the heck does that mean? 2.5 E6. Anybody know? That's scientific notation. So that means 2.5 times 10 to the 6th. So that means 25 with 5 zeros. So that's how many millions, which now we're into the trillions. And what would happen if you put 100 in here? What do you think? What's going to happen if we put 100 in? Error. Right, so if we put in 100, we get an error. So that just tells you it's too costly, but why mathematically are we getting an error? Because I'm dividing by 0. Remember we just talked about with our anticipation guide that we can never divide by 0? So if we put 100 in here for x, look at what our denominator is, 100 minus 100. So that's why that says an error there, okay? So this is our important concept we're supposed to cover today that you may not have seen, and that's this idea of domain, okay? The domain of an expression is a set, okay? Notice how I put set, I try to make it like stand out. A domain is not a single number or a couple of numbers, it's a set of numbers for which your expression can be defined or evaluated. So notice we cannot define 250 divided by 0. This is undefined, right? It's undefined. We cannot define that expression. And it's undefined for x equals 100 because 100 minus 100 gives us the 0. Any other number we put in here for x will give us a value, okay? So in this particular case, for this rational expression, the domain using set builder notation, not for the application now. The application with the percentage, we can't put -% in. Now we're just looking at the mathematical expression. So for this expression, which is just has no meaning now, but just for that expression, the domain in set builder notation is the set, because the domain is a set. The set of all x such that x does not equal 100. So in other words, you can pluck off any number from the number line and put it in for x, and you will come out with an answer. You can evaluate it. Why don't you sit right here? There's plenty of room here, okay? All right? So this is the domain. This is what we call the domain. So if you tried graphing this expression on your calculator, at the number 100, something funny is going to happen. Okay, but we won't go there just yet. Something funny will happen on your calculator. Okay, because it can't compute the value at 100. Right? So the domain is just what number can I put in here and actually churn out another number. And I used to tell my students last year, think about what you put into your gas tank. You know, some of you will have diesel gas engines. You wouldn't put in regular gas or vice versa. You wouldn't go ahead and put sugar in there, right? It's going to jam it up. So think about the domain as what numbers, first of all, is going to jam up my expression, okay? And that's the number that's not in the domain. Okay, so the domain is the set of all real numbers except for 100. So let's move along. So when can a rational expression not be defined or evaluated? When can it not be defined or evaluated? Right, when the denominator equals 0. Right. So right now, that's the only thing you have to think about, nothing else. All right, so I want you to come up with a rational, oh, I used the word function, sorry folks. This should say expression. Function, we've got to wait a couple days. A rational expression, any rational expression that has a domain of all numbers except 10. 10 doesn't work, it gunks it up. So you come up with your own division problem where you can put any number in the world in there for the domain except for 10. Someone want to yell out a couple of their answers? Anybody? Nobody. Orlando? 2x divided by 10 subtract x. Can I put a 10 in there? Nope, that will make the denominator 0. That's okay. Anybody else? Curtis, did you have one?
Isn't that to be a polynomial?
Well, you give me what you have.
5 divided by 10 minus x.
This is a polynomial. It's a monomial. It's a constant term, and that's a binomial, right? So you're set. You have the division of two polynomials. So that's correct as well. One more. Anybody got anything different than 10 minus x? No? How about x minus 10? Would that work? Yeah. How about x squared minus 100? Ooh, yeah, that would work. Okay, we'll get there. All right. So we set the denominator of a rational function equal to 0 to find the numbers that we're going to kick out of the domain, okay? We're going to set it equal to 0 so we can see what numbers are going to gunk up this expression. So find all numbers that must be excluded from the domain for each rational expression, and then we're going to write the domain. Remember, when you write your domain, you got to start off with your little curly braces because a domain is always a set. Eric? All right. So the first problem, can we have 0 in the numerator? Yeah, it's okay to have 0 in the numerator, but it's not okay to have 0 in the denominator. So when we set this denominator equal to 0, we get what kind of equation? It's not undefined because we don't have any x values. What kind of equation is that? The name for that equation, does anybody know? An equation with the 2 as the highest exponent. Is it linear? It's quadratic, right. Okay, so there's a couple ways you can do this. There's a way that's always going to, like, where you'll probably 9 out of 10 times miss one of the solutions. I'll show you that way in a minute. But there's always a way that you'll always get both of them, and that's to factor this. So this says you have the difference between a perfect square called x squared. So you put that in the first factor. And 25 is a perfect square. That's 5 times 5. And since your middle term is 0x, you don't have it, you just put a plus and a minus here. So these are very easy to factor. And then you set each factor equal to 0, and you have a baby linear equation to solve. That's going to be 0 when x equals negative 5. And this one will be 0 when you have x equals positive 5. So those are the excluded values. The excluded values, x cannot be plus or minus 5. Because if I put a 5 in here, I'll get 25 minus 25, and I'll gunk up the answer. If I put a negative 5 in for x and square it, I'll still get 0 in the denominator. Okay? So this is what a typical student does. And I know you're not typical, right? You're not typical. You would never do this. This is what a typical student does. X squared minus 25 equals 0. And they go like this. X squared equals 25. Oh, I'm going to take the square roots of both sides. X is 5. Okay. You see, they get one answer. Every time you see this, you should be, a lot of times, except for when 0 is your only answer, be expecting 2 answers. So the way to get around this is to remember what we learned on Friday. When you take the square root of x squared, if you take the square root of both sides, when you write that square root sign, the problem you're having is because if you've only been taught that the square root of x squared is x, when you assume x is positive, then you're going to just get one answer here. But what did we say the square root of x squared was on Friday? Absolute value of x. And this says, what's the positive square root of 25? 5. Now, when you look at that equation, you know you got two possibilities because there's two numbers whose distance from 0 is 5. X could be a positive 5 or x could be a negative 5. So folks, to avoid that error, this is the key right here. If you are in the habit of putting a little square root sign over x squared, you must say that the square root of x squared is the absolute value of x. Then you'll remember two answers. Or you can factor this. Your other choice is to use the quadratic equation on x squared minus 25 equals 0. It's a lot of work, though, for something you can do very quickly. So the domain here is all x except x cannot be 5 and x cannot be negative 5. That's what the domain looks like. You can do plus and minus if you want. Yes, Brendan, that's fine. You can go like this. I don't mind shorthand as long as you represent it as a set. That's the most important. Remember, your domain is not this. That's just the excluded values. Okay, what about the denominator on the second one when we set that equal to 0? Now we've got to remember how to factor. So the way I teach my students is what factors of 16 differ by 6, because that's its subtraction sign there. 8 and 2. And the 8's going to have a subtraction in front of it, and the 2's going to have, so if this, oh, you can't, oh. So x equals 8, or x equals negative 2. So those are the excluded values. X cannot be an 8, and x cannot be a negative 2. So your domain here is the set of all x except x cannot be 8 and x cannot be negative 2. Sure, go ahead. You can put a semicolon. You can put any, not a colon. Yeah, yeah, if you want to, that's fine. I just like to write and, but yeah, you can put a colon. Okay, so you can see here that this involves the factoring section, which is P5. So depending on how your factoring is, you may have a little more work than other people to do, or maybe most of you need a review on factoring. Okay, so that's going to be up to you to do. Okay. Any questions on how you find the domain for a rational expression? Any questions at all? Because I'm just going to move right along here. Okay. All right, so how would we reduce this fraction? Divide top and bottom by 3. 12 divided by 3 and 15 divided by 3. Why am I allowed to do that? Doing the same thing to the top and bottom, but really what I'm doing, folks, is I'm dividing by 3 divided by 3, which is 1. And you're allowed to divide a number by 1 without affecting its value. So if I take 12 and divide it by 3, I get the number 4. And if I take 15 and divide it by 3, I get the number 5. So we consider this reduced to lowest terms. Okay? Another approach would be to take 12 and 15 and to prime factor it. Prime factor the numerator and denominator. So 12 is 2 times 2 times 3. Those are all prime numbers. And 15 is 5 times 3. And then that's your first step. Then you look for a common factor that they both have. And you can see that they both have 3 as a common factor. And then you divide the numerator and denominator by that common factor. That's what you're doing. And that's what you do every time you put that slash through. That's essentially the concept behind what you're doing, is you're dividing by 1. When you go the other way, when you go from 4/5 to 12/15, you're multiplying by 3 over 3. You're multiplying by 1. Okay? How do you have that look? Are you confused about something? Slash over what? Wait a minute, I can only answer one question at a time. I know I'm talented, but not that time. No. Go ahead, Liza. You don't have to do it like I did. I was just showing that. See what Eric did here with division, where you could see the division by 1? I was just showing you where the 1 is. Okay? Because a lot of you are weak in your fractions. You could have written this like this. I could have written that the same way. And that's just the number 1. So I was just showing you where the 1 occurred. Some of you have never even factored it out. You just go like this. You put the slashes like that. When you learn that method, hopefully you learn the idea behind it. It's okay. I don't care how you reduce it, but I want you to understand that you're finding a common factor to the top and bottom, and you're dividing it out. Eric? Yes? Yes? No, no, no. Come on, let's not get into taking off points. Jonah? Do you have a question? I was just saying. Okay, here's the reason for this process. I know probably 100% of you could say 12/15 is 4/5. I hope 100%. And most of you might do something like this with the slashes. Why am I bothering doing this when it doesn't appear to be necessary? Because in 1 second, we're going to be asked to reduce these right here. Okay? So if we're unclear about the process with numbers, we're not going to be able to translate it to rational expressions. So this method right here, where I say factor and factor and find a common factor, even though you don't do all that work out, that's what allows you to put this slash here and call this 4/5. That's the concept. You're dividing by 1. That's critical. So you notice how I did this 1 here? I call that a foo-foo. And this is invented by this guy named Aaron Einstein, and he put it in the mathematics teacher. You need to find a fancy form of 1. That's what foo-foo stands for. You need to find common factors in the numerator and the denominator. Okay? So if we come down here now to rationalizing expressions, look, mandatory. I can't make it any bolder. I suppose I could have put it into caps. Identify, it should say any excluded values from the domain. Sorry for the typo. I'll fix that right after class. Identify any excluded values from the domain. Be sure to factor the numerator and denominator completely. Identify the common factors, your foo-foos, and then divide them out. Okay? So let's first start here. What are excluded values from the denominator here? Again, you have to know how to factor this. To factor that, factors of 8 that differ by 2 of 4 and 2. You set those factors equal to 0, and you find your excluded values are -4 and 2. So your excluded values are negative. X cannot be a -4, and X cannot be a 2. Those are 2 values that are excluded. Okay, yep, Logan? You have to do it prior to factorization, before you reduce. You have to find the values of X that will make the original expression. Okay? Sure. Megan, sorry? Because I'm solving to see, so in order to find the answer, so here's a multiplication problem, Megan, right? And so I want to know when this multiplication problem is going to be equal to 0. So to do that, I have to set each one of these factors, X plus 4, I have to ask, when does that equal 0? It's when X equals -4. And then I have to ask, when does X minus 2 equal 0? That's when X equals 2. Okay? Okay. Does not equal 2. You can put a comma, I don't care what you put. Okay, so how am I going to reduce or simplify this expression? What do I do first to simplify that? Now, If all you thought of when you reduced regular old fractions was putting these slashes, looking for things that were the same, without this concept that they're factors, that it's multiplication, you're going to make a really big mistake. Because you're going to say, oh, an x squared and an x squared, an x and an x, a 2 and a 2. Is that multiplication? Okay, so the only way you can reduce something is when it's all multiplication, top and bottom. You have to put arms around it. That's little parentheses. Keep it safe. Keep your grade safe, okay? So let's do it. What's that first one? X squared, I already forgot. Plus 3x minus 10?
Yes.
Over x squared plus 2x minus 8. Factor, 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 factor. So let's factor the top. What's the, yep.
You're just saying like the multiplication. What if like there's only one multiplication of addition?
All right, well, let's do that in a second, okay? Right after we finish this. So this top is x plus 2 times x minus 5. That is now a multiplication problem. Do you see how I put my arms around it? The other way around, thank you. I'm already starting to hurry because I can see the class is almost over. There we go, okay? X minus 2 times x plus 5. So I factored the top completely into prime factors. Now now look at the top. The top will often help you, but not always. I got x minus 2, x plus 4. So I factored the top and bottom. Can I find a factor that's common, a foo-foo? Are there any foo-foos? Yeah, what is it? X minus 2, right. So there's my big fancy form of 1. So this reduces. Now keep the arms around your binomial because x plus 5 is not the same as x plus 4. So keep your arms around it, keep it safe, and that's your answer. Okay, x plus 5 over x plus 4. If you remove the parentheses, that evil lurking temptation comes up through your hand and your wrist, and you want to cross off those x's. But it does not say 5 times x over 4 times x. Okay, it's very different. Now, Liza, you had a separate question?
Yeah, like let's just say x.
Plus 4 over x squared, something like that?
Yeah, but then you also have multiplication.
And where?
Like,
Here?
Or,
Or,
yeah, like that.
okay, can't do anything with that. Nothing. Because what this means, folks, is this denominator, folks, belongs to that and that. You would have added 2 fractions. What must be true about fractions when you add them? They had to have a common denominator. So to get to this step, you would have had this. X squared over 2x squared plus 4 over 2x squared. Now, if you have that problem, you can simplify each individual fraction, but you cannot simplify it like that. Okay? So remember, this denominator belongs, if there's an addition problem on top, to both. So you can't start taking away the x squared from here and the 2 from here because the 2x squared was the denominator that they both had because it was originally an addition problem. As I try to tell you, and I will often remind you for the whole semester, if you can separate what we can do in algebra and in any kind of math with adding and subtracting and what we do with multiplying and dividing, you will be eons ahead in terms of your mathematic development. Okay? Yes, that's the final answer. So here's one that could get you in trouble, similar to what Liza just asked. First of all, what's the excluded value from b? What can't x be? -4, because if I put -4 in the denominator, I'm in big trouble, right? But this is where if you you look at your numerator, you say, I can't factor that. That means it's prime, so put your arms around it like that. You can't factor it. You look at the denominator, you say, I can't factor that either. Put your arms around it. And unless your arms are around the same person, you're in trouble, right? Okay, you can't do any dividing here or multiplying. All right? So this is already reduced. This would be just like the number 2 divided by 3. They're totally different numbers. They're prime already. You have one prime entity divided by another prime entity. It is done. Complete kaput. Okay? So this is already simplified. And if you were thinking about what you would have had to add to get that expression, you would have had to add these two fractions originally to get that one single fraction. They both share x plus 4. So you have no right to take x and 4 from any part of it. Okay? In your mind, you have to see the difference between that expression and this expression. These are very, very different. 8x divided by 4x is the number 2. Because those go and that goes, because it's all multiplication. You can multiply by 1. This is all addition, very different. Okay, so take a few minutes to summarize. We don't have a few minutes about adding, subtracting, multiplying, and dividing. We know adding and subtracting, everything has to look like. Alexis, could you just get that door for me? Because in a few minutes, like 6 minutes, it's going to be busy. So adding and subtracting fractions, they got to look like, which means they have to have common denominators. This is probably the area where if you've taken math 096 or 106 here, where this was like your last 3 or 4 days of class, you were dealing with this. Division of fractions is a key idea with division of fractions that you have to remember. If I was teaching math 090 or even 105, I would spend some time with you to show you why this works, but unfortunately, we can't do that in 107. We just have to know how to do it. Does anybody know what A divided by B divided by C divided by D is? D over C, right? You change division to its inverse operation, which is division changes to its inverse operation, multiplication, and you can't just take a division problem and change it to multiplication without also changing C over D to its reciprocal. Okay, so let's take a look at a couple of, yep, Cicely?
In that problem, D and D not equal 0.
That's right.
D equals 0. With the original, if you're trying to find the domain for the original problem,
No.
you have to say C.
Well, in this case, you'd be focusing here. What would be the chances of C equaling 0? Let me think about it for a little bit, okay? And we'll take a look at it right after class. Okay, so this is a type of problem you're going to see in section P6. It looks really scary, okay? The first thing you should do is notice its division. You should change that to multiplication by the reciprocal. So the first thing I'm going to do is change dividing to multiplying by the reciprocal. That's it. And then I look to see, do I have any prime factors anywhere? Any prime factors where I can just put my arms around it right now? Which one? X plus 4. That will give you a hint. Because usually, not always, if there's an x plus 4 in the numerator, there's probably an x plus 4 somewhere in the denominator. But not always. Just might give you a little clue as to how to factor some of these. This first fraction, you should almost be like this with it in the factoring, automatic, because it's the difference between perfect squares there. So that factoring should almost go as quickly as this. I'm just going to put one big numerator now because that multiplication sign doesn't do anything. I'm just going to squish them all together in the numerator. X squared minus 16 is x minus 4x plus 4. And now I've just got to figure out how to factor that. So I say to myself, oh boy, 5 is a prime number, so there's only 2 factors, 5 times 1. And guess what? It happens to add up to 6. So I have x plus 5, x plus 1. So my excluded values here, if I look at this first denominator, are plus and minus 4, and that covers my second denominator. Okay? So now I look for my foo-foos. So x cannot be plus or minus 4. Where are my foo-foos? Where are my fancy form of ones? My factors that are the same in top and bottom. X plus 5 and X plus 5. Anywhere else? X plus 4 and X plus 4. So I have left X minus 5 over X minus 4 times X plus 1. That's as simplified as it can get. I do not require you to multiply that all out on the bottom. You could, if you wanted to, you could leave it like this. If you wanted to, you don't have to. Okay, and the reason why I ask you not to leave it like that, because then that evil temptation to start canceling terms comes in. So whenever you have more than one thing, at least put it in parentheses so you can say to yourself, is it the same top and bottom? Yep. It's not stupid. Go ahead. Can you not pack up yet? We still have another minute and people are asking questions. So just to be courteous to your fellow students. Yeah. Because I'm trying to reduce this from highest terms to lowest, just like that 12/15. So X plus 4 over X plus 4 is the number 1. So I can get rid of that. And X plus... Yeah? What went away? I didn't. This is still all multiplication. This has still got all times between it. Okay? That's what those parentheses mean. Okay? I didn't get rid of the multiplication. I just decided to join them in holy matrimony, see? With one fraction about anything. Yeah. Yeah, that's what Cecily was getting at. Now notice, so it's 10 of. How about if I just leave that to start Wednesday's class off with? But the only thing you have to worry about is plus or minus 4 in the original problem. You don't have to worry about the negative 1, but maybe you do. So let's think about that. What is the domain here? That's the question that is being asked. We'll start there on Wednesday. Please, one at a time, return and take off your name for